Hey everybody, so I just had a little bit of an issue. I recorded all of my lessons for the week, and for whatever reason, the recording software decided to shut off the microphone. So here I am re-recording everything, but that's okay. So last day, we looked at ray diagrams for concave mirrors. So if we remind ourselves, a concave mirror is reflective on the inner surface. So this is what we call a concave mirror. And today we're going to be looking at ray diagrams for convex mirrors. So if we're looking at convex mirrors, they are reflective on the outer side of the reflective surface. So this is what we call a convex mirror. You see these all over the place. Most of the time, you'll see them in like a convenience store, or perhaps in the corner of a parking garage. They are flexed outwards, so they do help us see around corners, which is great. You also sometimes see them on, like if you have like a bigger vehicle, a truck that you're driving, you might see small secondary mirrors on your side mirrors there that help you see around your blind spots. So that's typically where you see these convex mirrors. So let's go ahead and do the array diagrams for convex mirrors. So they will follow the exact same rules that we did for concave mirrors, except we're flexing outwards instead of flexing inwards here. Good way to remember it is caves go in. In any case, so remember that I tried this with a ruler the other day. It wasn't working great on my screen, so you guys should use a ruler, but I'm going to freehand this. So I'm going to draw my principal axis here, and I'm going to draw my convex mirror. Now you'll notice that the convex mirror, as it is curving outwards, has its focal point behind the mirror, and its center of curvature behind the mirror. So I have my center of curvature and I have my focal point here. And so I'm able to then use that to help us solve it. So let's say I place, and you can place your image anywhere, it doesn't matter. Let's say I place my image right here, my image, or pardon me, my object right here, and make it any height, and we're just going to follow our rule. So my first rule, you're always going to, and this should actually be touching the principal axis, but anyways, my first rule is you're always going to have a light ray that runs parallel to the principal axis, and it will strike the mirror. Now, in this particular case, for those of you who play hockey or baseball or whatever it might be, maybe you'll recognize that if I tossed a ball along this line and it hit this curved surface, that it would likely bounce upwards. Okay. Now, how does it bounce upwards, or at what angle? It's always going to bounce at an angle that is as if it came from the focal point, something like this. Okay. My second ray that I always produce is a ray that would have come from, as if it was coming from, or pardon me, going towards the focal point. So I'm going to leave the tip of my arrow, and I'm going to go towards the focal point. Now, of course, this light ray cannot go through the mirror to hit the focal point, but when it does strike, because it's going towards the focal point, when it reflects, it's going to reflect parallel to the principal axis. And I get to see my reflected line there. Now, the two reflected lines, so the first one that we drew up here and this one down here, they'll never run into each other. They're not going to hit each other. But our eyes are able to extrapolate where they would have come from. And so they actually would have joined behind the mirror somewhere around here. So if we had to use that to describe our image using Lost, I would say that the location of my image is closer to my mirror than the object. I would say that its orientation is upright, right? Same orientation as the object itself. The size, of course, is smaller. And the type of image, now these are not real light rays that have produced this image. This image is produced by virtual light rays. So we have, of course, in this case, a virtual image. And my pen has seemed to stop working. And there we go, virtual image. And that's it. That's as hard as it gets. So it doesn't matter where our image is in front of our mirror, as long as it's a convex mirror, it will always produce these four outcomes for describing the image itself, and that's how you would produce the actual light ray. Now, how do we know if you've done this correctly? Now, remember, I didn't actually measure this. You could take a line, connect the tip of the object to the tip of the image, and it should cross right through the center of curvature if I've done this correctly. And of course, I just freehanded that, but you'll be able to actually produce an image that would line up with the center of curvature as long as all your measurements have been made correctly. So that's pretty much it. That's ray diagrams for convex mirrors. If you guys have any questions with them, please feel free to email me, and we'll see you on the next lesson.